Hey, what's up, Algebra 1? Catlin here helping you out with your last lesson for this week, Lesson 4 in Unit 5, as we're starting to look at exponential decay. And we went over this problem in class where we saw a car price go down over a certain amount of time. And so I wanted to help you out with this if you needed some assistance. And so we're looking at this phone that originally sold for $800. And then they're saying that it loses 3/5 of its value each year after it has been released. That makes sense. Older model phones usually don't cost as much to buy new. So let's look and see what would happen. After 2 years, how much is the phone worth? Well, we found out that there was a faster way to do this because we could find out what 3/5 of this is by doing, 3/5 times 800, and that would tell us how much they're losing. But instead of putting this in terms of how much they're losing, we thought of putting this in terms of how much they're keeping in value. So to do that, we would start with 800 and we would multiply by the remaining amount that's left over. So like if they lose 3/5, then they're keeping the other 2/5. And that would represent 1 year. And so if we're doing that 2 years back to back, then the second one would be another multiplication by 2/5. And so we can write it like this, which is really the same as writing 800 times 2/5 to the second power, because you're doing that amount that I keep back to back exponentially. And so this is what I'm going to type in to find out how much this is worth after 2 years. So let me go to a Desmos calculator. Let's clear out what I've got in there. Let's put in our number. We start with an $800 phone. We multiply by the 2/5 that we want to keep, and we're going to raise that to the power of 2 because 2 years have passed. And that means the phone's going to be worth $128 a couple of years later. So we get $128. Now, if I wanted to write an equation for this that would help me find the amount the phone would cost after T years it has been released, the T is the number of years. That's going to replace our time of multiplications by 2/5. And P is going to represent the amount that the phone is worth after I do all of this. So I'm going to replace 2 with T, and the answer that we're going to get with P, the value of the phone. And so that equation would, the value of the phone, P, would be equal to the starting amount of the phone times its growth factor, which is keeping 2/5 every year to the power of T. And there you go, guys. That is how you set up a exponential decay type of situation, and I hope it was helpful. See you.